Welcome, ladies and gentlemen. So what I'd like to do is show you how to write the equation of a line that goes through a given point and is parallel to another line. And we're going to write that equation in slope-intercept form. So you can see in each of these equations, I have a point that my line goes through, as well as I have an equation that my line is going to be parallel to. And what we're going to do is we're going to write our equation in slope-intercept form. So when writing an equation in slope-intercept form, basically what we need to do is identify the slope and identify the y-intercept. Now, the important thing, there's a couple important words that we're given here. First of all, we're given that we want a line that's going to be parallel to a given equation. And so we need to remember, well, how are parallel lines related to one another? And parallel lines are related to one another, meaning that they're never going to touch, right? Remember, like back in your geometry days, parallel lines do not ever intersect. Do not ever intersect. Do not intersect. So since I have the same slope, if you look at this equation, the line that my graph has to be parallel to is y equals 3x minus 2. Well, in this case, you can see that 3 is going to be the slope, and y is going to be the y-intercept. If two lines share the same slope and the same y-intercept, then they're exactly the same, right? It's exactly the same line. So they're not going to share the same y-intercept, but they are going to share exactly the same slope. So therefore, I now know that m is equal to 3. So to write my equation so far, I have y equals 3x plus b. So now I'm given the slope. I know what the slope is now, which is 3. And now I just need to write it that it goes through a point. So automatically, when I think of slope and point, I think of point-slope form. And remember, point-slope form can be written as y minus y1 equals m times x minus x1, where x1 and y1 are represented of your point that the line has to go through, where just the regular y and x represent any point that lies on the line, and m represents your slope. So now I'm going to plug in the information that I have. So I have y minus y1, which is 8, equals m, which is 3, times x minus x1, which is 2. Now, given this information, I apply distributive property. I have y minus 8 equals 3x minus 6. Then I add the 8 to both sides. And I have my equation written in slope-intercept form, y equals 3x plus 2. And there you go, ladies and gentlemen. You can see that the slopes are exactly the same, and the y-intercepts are not exactly the same. And there you go, ta-da. Now, I like using slope-intercept form when doing this, when using parallel and perpendicular lines, because it doesn't get confusing. Now, the next one, I am going to use a different method. I'm not going to use point-slope form. I'm going to use the slope-intercept form the whole time. But I just caution you, be careful, because what a lot of students do when they do it this way is they try to keep the y-intercept the same. And that's why I'm trying to make a very big point. The y-intercepts are not the same unless they say they're exactly the same lines. So in this case, again, we have a parallel line. So I have my new equation. Since my line has to be parallel to y equals 1/4 x minus 6, the slope has to be exactly the same. So I know my slope for my new equation is going to be 1/4. So when I write my new equation, I will like y equals 1/4 x plus b. And what students always do all the time is they rewrite -6. No, it's b. We're trying to figure out what the new y-intercept is. So now, rather than using y1, x1 in point-slope form, I can say, well, x and y are going to represent the points on my a point on my graph. So I'm just going to represent them as x and y, and I'm going to plug them in for x and y. Here, I plugged them in for x1 and y1 because we had multiple x's, and I said I wanted x1 and y1 to represent the point that the graph goes through. Here, I only have one y and x, so I'm just going to plug them in for that. So therefore, I obtain 3 equals 1/4 times -2 plus b. Now, I will also say that even though I'm doing it two different ways, if you wanted to solve this problem using this method, using that point-slope form, perfect, go ahead. If you want to use this method on that problem, perfect, go ahead. Two different ways, but really it's the same thing. You're just using a different formula here. So now I need to multiply 3 equals times -1/2. So that becomes -2 times 1/4. That reduces to a -1/2 plus b. Now I need to solve for b, which is my y-intercept, which I'm trying to figure out, which is going to be 1/2. So now I have 3 plus 1/2 equals b. I got to get common denominator, so I'm going to multiply by 2 over 2. And I get 6 over 2 plus 1 over 2 equals b. And I get 7/2 equals b. So now I know what b is. Now I just solved for b. I already know what my slope is. So now I can write my equation on my line. My equation on the line is going to be y equals 1/4 x plus 7/2. OK? And there you go. For the next example, I have 1/2 comma 1 is parallel to x equals 7. Now this one might get a little confusing because you're like, well, what is even the slope even on this one, right? It's not in slope-intercept form. So the main important thing to understand about this problem is a lot of times, even if you get stuck, even with these other two problems, if you get stuck, graph the information. Take a look at what it looks like. And we've already covered graphing, so hopefully you understand that x equals 7 is going to be a vertical line when x equals 7. So 1, 2, 3, 4, 5, 6, 7. Right? X always equals 7. So it's going to be a vertical line at the 7 on the x-axis. Then if I have a coordinate point, I want my graph to go through 1/2 comma 1. Well, if it has to be parallel, that means it has to be a vertical line. And if it's a vertical line, it has to go through when x equals 1/2, then my only option is to write the equation x equals 1/2. Because at x equals 1/2, that goes through the point 1/2, 1, right? It goes through all the points where x is the 1/2. And that produces a vertical line, which will be parallel to that. And the reason why this one's a little bit difficult, because the slope is undefined. Vertical lines have an undefined slope. So using typical methods isn't going to be as efficient. But if we can visualize and see that, oh, vertical line, OK, I'm going to have to create a vertical line, which goes through that point. So there you go, ladies and gentlemen. That is how you write the equation of a line through one point and parallel to another. Thanks.